Hey y'all, it's Mrs. Peters. We're going to fill in a foldable that's going to collect some of the information we've watched from the previous video and put it all into one nice, neat, um, easy to read, hopefully, spot. So you're going to have to fill this in and you're going to have to write some things in. First thing I want to do is I want to talk about a square. Remember now, a square is a very special quadrilateral. It has all its sides are equal. Okay, and all the opposite sides are parallel, as well as all our angles being equal. And the diagonals are also equal. Now, diagonal, if you want to look at a diagonal on a square is a line that goes from a corner to a corner. All right. So these dark lines that I just drew that I'm going to put into color, into red, this is a diagonal, and this light pink is a diagonal. And if you notice that they happen to cut each other into two equal parts. So this piece and this piece here are equal in length, as well as this piece is equal to this piece here. And that's the special thing about diagonals. Now what we're going to do is we're going to use this information that we're figuring out about shapes to prove that we have a shape, a specific quadrilateral. Maybe maybe we have a square, maybe we have a rectangle. So it's really important to know this information. So with that said, in a square, all sides are equal, opposite sides are parallel, all the angles in the square are equal, and all the diagonals are equal. In a rectangle, we have opposite sides are equal and opposite sides are parallel. All the angles in a rectangle are equal, and the diagonals also are equal. Let's look at a rectangle here real quick. Here's a rectangle, and if we look, here's our diagonal in a rectangle, and here's another diagonal in our rectangle. And we'll notice that our length of our diagonals are equal. Okay, this whole length is equal, as well as having this piece here and this piece here being the same length. So we also have our diagonals bisecting each other, so that where they meet in the middle, right here, oh, let me see if I can get a better color. Right here, this spot right here cuts or is a bisecting point. Okay, next, let's talk about our rhombus. Remember now, a rhombus is a parallelogram whose all the sides are equal. Remember, a square is a special type of rhombus. Okay, opposite sides are parallel, which means it's a parallelogram. And all the diagonals bisect each other. In other words, we have a midpoint in our rhombus. So a rhombus is something sort of like this. There's my rhombus. Remember now, my rhombus is a wacky. All my sides are equal, but I have no understanding of my angles. So here's my diagonal in my rhombus. They do cut each other in half, but they are not the same length. So I do have a midpoint issue going on with a rhombus. All right, now a parallelogram. Opposite sides are equal and opposite sides are parallel. So let's look at a parallelogram. Here's a parallelogram. Right now, do I know anything about my diagonals? Well, my diagonals are still going to cut each other in half, but my diagonals are not going to be equal. So my diagonals bisect, and I still have a midpoint, but I have no information about angles at all. Notice that the rhombus and the parallelogram, we haven't put anything in the angles. Okay? A trapezoid, I only have one pair of opposite sides being parallel. Now this one is, the picture I just drew is a picture of a isosceles trapezoid with these two sides here being equal, and that only happens in an isosceles trapezoid. Not all trapezoids are isosceles. Okay, again, I know nothing about my angles, and my diagonals will bisect, but we're just not going to worry about that right now. And that's all our information about quadrilaterals. All right, so fill it out. We're going to be using this information to help us when we are doing a little bit of very simplistic proofs. You're going to graph some stuff in the coordinate plane, and we're going to look at things like how can we prove that we have sides equal. And if you look at the top of your paper, you'll notice I've put in there how to figure out if you have the same length. Well, you're going to use the distance formula. How are you going to tell if you have angles equal? Well, let's find the slope and compare and see if we have perpendicular lines. Perpendicular lines meet at a 90-degree angle. How do I know if I have a midpoint or if I'm bisecting? Look at the midpoints of your lines. If your diagonals have the same midpoint, you have a bisecting diagonals. And how do you tell if you have parallel lines? You're going to find the slope. So in each of these cases, when we're looking, we're either using the distance formula, okay? We're looking at slope, so slope is always handy to find, or we're looking at the midpoints. And guys, you know how to do this. I know you can do this, and we're going to work on it in class. Talk to you then. Take care, and bye-bye.